Thank you so much. Yes, once again, great to be again with you this year. Things change. We have something new to tell you about. This is Helidon 4, and I'm really happy to present it. So, a few words about me. I'm Dmitry. I'm now in Sofia, Bulgaria, and I am writing code at Oracle and sometimes giving presentations. Yes, most of the time I write code, and I'm really happy that I present exactly about the product I'm working on, not just something else done by somebody else. But this is something that we do and something that I'm part of. And that's really cool. At least I find it very cool. So we have only 45 minutes. I have a really lot of things to tell you, so I'll be really quick. So whenever I have some questions, please post them, and maybe at the end I will be able to answer them. If not, just ask them in Twitter, ask them in Mastodon, ask them in LinkedIn. I'll be there to help answer them. Okay, so tell me, as the session is called Revolutionizing Services with Helidon 4, let me first do a small introduction of what Helidon is for those of you who don't know. Because actually, once again, we are like every year on this conference, and Helidon is quite presented here, so I'm happy about it. But for those who joined at the first time, so what about Helidon? So it's a framework for developing microservices done in Oracle, actually. Um, it has everything you need. It's cloud native. It's really small. It's really powerful. It's really, you know, gives great performance. And we have some unique stuff that we like, for example. So first of all, you have to know that this is a server, but not a servlet container. So this will be interesting maybe a little bit later. So we have a philosophy of using as few third-party libraries as possible. So we are always self-contained as much as we can. And we also have a philosophy that we try to sync with the latest Java release. And our major releases are usually synced with Java releases. So we kindly ask our customers on every release to move to next version of Java and move to next version of Helidon. Yes, and have multiple flavors, which I'm going to talk about. So our philosophy is we are very simple. We are transparent. So unlike other Oracle projects, we are totally open source. We are all in GitHub. We are under Apache 2.0 license. That means you can contribute and submit issues. Everything is public. So we try to solve them as quick as possible. And well, once again, we try not to do tricks or cheating. We try to do very pure Java code and optimize it as possible. And as I told you, our main goal is to use as few external dependencies as possible. And this we encourage our customers to always be up to date and always use the latest technologies. So from the very beginning, as you see from this history chart, from Helidon 1, we already used Java 8, from the Microprofile 3.2. From Java 2, we started using Java 11, which introduced modularity there. And Helidon is modular from the very beginning, so you can enjoy the modularity of Java. Then we moved to Java 17, and we have moved everything to Jakarta namespace, which is great and awesome. And so once again, we're following the latest tendencies. And now with Helidon 4, we move to Java 21 and Microprofile 6. That means that once again, we are using the best available now. And I'll tell you later why it is so important, actually. So, and we are one of the few frameworks that provide different ways of distributing your application. So, of course, we all know hollow jar or fed jar. So you can do a jar file and you just run it, and then you have your microservices up and running. But what we also do is you can create custom image because, as once again I told you, we are modular from the very beginning, and since we are modular, you can enjoy the modularity. So you can create custom image with your application. Just throw away all the software you don't need, all the modules you don't need, not only from Helidon but also from JVM itself. That's why your image will be very small and it's faster and it's much more secure. And of course, we are, I'll be quite honest, we are one of the best in GraalVM. So we're really fast and we provide really awesome support for the stuff that many people actually don't support. So 99% of our code actually goes to or can be compiled to native image, which makes us quite unique out here. So you can compile the application to just an executable jar and run it, and it will be really fast. Well, you will not be able to enjoy the hotspot JVM optimization, all of that stuff, but it will be extremely fast for, I would say, shorter runs, if you have such kind of shorter runs. But what makes us quite unique is that actually with Helidon you get two programming models which are available to you out of the box. So first of all is Helidon SE, which stands for Java SE Standard Edition or something like this, or close to Java code. We upgrade our own reactive non-blocking framework, which is very, very fast, and which is, as you see from the code on your left, is that it's a pure Java code, and well, you just run it and it works. You can even run it from the IDE with a play button. And the other is Helidon MP. So we decided that just having a framework which is pure Java is awesome, but we need to go standards, and we chose microprofile as our standard. So I'll tell you later about it. But microprofile idea follows this, inspired by Spring ways. That means that you put some annotations, a lot of magic happens underneath, and you enjoy wonderful microservices which do this stuff. So I'll tell later about it. So, but once again, our main idea here is that architecture is based on, we use Netty underneath. Netty is proven to be one of the fastest network frameworks. So it's asynchronous. So on top of it, we build this reactive Helidon SE. And then we also use Helidon MP, which is built technically on top of Helidon SE. So this layered architecture gives us, ability to actually interchange the layers between us, and that's why we are quite modular and very easy to upgrade. So as I told you, Helidon SE, we have to introduce something fast because we require a lot of performance. And back to those days, like a few years ago when we started Helidon, reactive was the fastest way to achieve, the best way to achieve better performance. So we created our own reactive model, programming model. So we use a lot of reactive streams, we use completion stage, we use all this non-blocking and back pressure stuff. So it's for really highly concurrent services. And what is good is it has feature parity with microprofile. That means we can do what you do in microprofile, you can do the same with pure Java code, and it will be quite fast. So, and as I told, our philosophy actually is that we think that we don't want to take outside dependencies because Helidon is used in quite secure environments, should be banks or governments, and they are very, very strict about what dependencies you have to do, you have to include. And that's why we decided to create our own engine for reactive operations, which has no dependencies on other, for example, Project React or other implementations. And we created our engine based on the newest Flow APIs, actually. As you can see, Java Concurrent Flow, this came in Java 9 or 10, I can't remember right now. This is a set of interfaces, and we created our own, engine, which was contributed by David Karnak himself, actually, the father of Reactive. And it's very tiny, it's small, it's very fast. We have our own constructions as multi and single. So that means that if you are familiar with Spring, you know them as Mono and Flux. They're quite similar, but we call it more normal way, I would say, multi or single. So for multiple operations, you have this multi, not operations, but values, multi, and if it's just single value, you just use single. And this is cool because with this comes quite I would say, nice set of reactive operators. Of course, if you have a programmed reactively, you only have to know flat map. This is for everything. Well, yes, it's not that big as reactive. Not reactive, but reactive, project reactive. Then it's just, I would say, it's endless. Every time I type control or command shift, not shift, but space to list me the operation, sometimes my idea simply hangs to load all of these operators. This is amazing. We have less of them, but they are quite powerful. And with this, actually, that we're small and powerful, uh, typically our performance is quite good. I would say sometimes twice as fast as our competitors for reactive operators. And yes, this is nice. On top of that, we built our reactive web server, which actually, delivers this server functionality in reactive way. So you create service in reactive. As you say, you create, you build it, then you start. It returns you a single or a completable feature. And you just wait for it to start and you can use it, which is good. There's only one thing about this. So, once you are reactive, you have to always be reactive. That means that you can't mix imperative blocking code with reactive code, actually. So for that, we have developed our own DB client, which can work with reactive databases with I would say, normal JDBC or blocking JDBC database in a reactive way, which means it starts in a separate executor, it wraps it in reactive constructions, and you can speak to your database in a reactive way with back pressure and all that stuff. And the same if you consume, for example, other services from other microservices, you have to have a reactive client. So we also made it. So this is good that now you actually have this full chain of reactive programming model can be applied from actually reading your data or consuming your data in reactive way, processing your data and returning your data in a reactive way. It's good, it's awesome, but I would say it's hard. You see, yes, to have performance, you had to be really good at reactive programming. So that means that back in those days, non-blocking reactive programming was the way to achieve good performance. But it was hard to write. It was hard to read. It was hard to maintain. It was almost, I would say, impossible to debug. So for hello world applications, of course, it works okay. But if you go to some production stuff and you start, chaining all of the calls, or for example, creating this callback hell, well, it was hard. And we completely understood this. And of course, well, for certain tasks, you can find really, I would say, expensive programmer who is able to get things right. He knows reactive programming. I personally knew 3 people who actually can do this right. I'm not among them. And yes, you will write your stuff in a reactive way, and it will be extremely good at what it does. But it is hard. So if we go here, back to this architecture, as you see, we have this Helidon MP. And we decided that on being on top of Helidon, I see this micro profile layer, which is a set of specifications, as you know, micro profile, or simply go to microprofile.io to find more about it. That means that we just implement as a vendor those specifications. And this gives us ability to work in this ecosystem. That means that whenever you have some code which is microprofile compliant, you just drop it into to Helidon, and it works. Um, Lovely. It's not only microprofile; I have even more specifications like Jakarta and Jakarta specifications like annotations, transactions, etc., etc. And you have even the standalone specification. That means, for example, if you have long-running actions, array, which is the Saga pattern, and it's microprofile based, you just drop it and it works out of the box. And it's nice. And once again, as I told you, why we are best in class, I would say, for GraalVM, because you have full CDI support, this injection, even working in GraalVM. So you can create your CDI application, CDI-based application, and just compile it to a native image, and it will work. We are really good at this. So, but there is one, I would say, small but drastic detail. It is blocking. The most of the APIs of microprofile are blocking, which means that well, you write it simple, but the performance is not that good, because if it's blocking, that means at some point you block your thread and your computer or your server or whatever it is, or cloud machine, simply waits for something, and you just wait and pay for it. This is nice. So actually, before Helidon, you have this straight up. Like, for example, you need performance, then you have to go reactive, because that's the way to gain performance. If you need a fairly standard application with not so much big throughput and with some easy coding paradigm, you go to microprofile, and you have to choose between those stuff, like how would you do and what will you do. So either high performance and big complexity, or I would say simplicity and average performance. Well, that was it. So how to get more performance? Actually, well, it's quite easy in terms of theory. You just have to add more threads, because you know that when a request comes, you just put it on a thread and it's processed in its own thread there. But Java itself is well, threads in Java are just wrappers around operating system thread, actually. And that's why they are quite expensive. To run a thread, you need 2 megabytes just for the descriptor of a thread. You need about 1 milliseconds to start a thread, and you have to switch between threads. Well, it depends on the OS, but it's 100 milliseconds. That means that even if you have a machine with infinite amounts of cores, you want to start them, well, you will need several minutes just to start all your threads. Well, something should have been done with this, and we come to so-called Project Loom. So, and this Project Loom is about I would say virtual threads, fibers, continuations, and well, something which can give you more threads than you actually do have on your machine. It's not something new. There were virtual threads or fibers in Python. In Kotlin, you have coroutines. In PHP, even in PHP, there was something. Of course, in Perl, if somebody codes Perl, you are amazing. I could not understand what's happening in this programming language. But yes, they actually experimented with this, and that's why in Project Loom, in early days, they even called it fibers and continuations. So this is what a research project, a fork of JVM, JDK, which allowed us to use this technology. So there were several JEPs actually first were open to the world, this virtual threads, and in 3 JEPs, they are now available out of the box in Java 21. I'm going a little bit ahead of time, but once again, it really took several years to develop them. But now, as we have it, what is actually happening inside? So in Project Loom, we have virtual threads. As I told you, this is a new construction, but technically this construction is the same as the normal thread by interface, by API. It's not a green thread because green threads, if some of you, I'm old enough to remember what a green thread was in early versions of Java. That was idea to run multiple threads on one thread. Here we have something different. We can run multiple virtual threads on multiple normal threads or carrier threads as they call them now. And that means the JVM manages it. And what actually is the management? So technically, virtual threads are like mounted on normal or typical or carrier threads, as we call them. Whenever a virtual thread blocks, the JVM recognizes this and offloads, unmounts these threads out of carrier threads, giving and mounts another thread which waits for it. So that means that where there is a gap in waiting, JVM simply puts someone else to do the job while the thread is blocked, the virtual thread is blocked. Whenever a virtual thread is unblocked, for example, there was a, I don't know, call to a database, and now the data has come. It's not blocked anymore. It's given to the scheduler of a virtual thread of JVM, and it is blocked to the first available carrier thread or put into some queue with some waiting to be mounted on carrier threads. So they use work stealing algorithms here for JPool. And well, cool is that you just have the same interface, the same APIs you used to have with normal threads. And you just use it. Underneath, it's implemented with continuations. It's not open API, it's internal API. And so technically, all the JVM was rewritten, not rewritten, but I would say augmented with this continuations yield function, which means that we know, for example, in if there is a blocking call, and we know that it's block or IO code, it will be we put this continuation yield. That means that whenever JVM gets to that point, it can actually create a continuation at that moment and upload the thread out of the carrier thread. So it works like this. So with this, we decided that it can be millions of threads, not just hundreds. Typical, server can handle up to 400 threads, I guess. Now you have millions of them. They're always daemon threads. They have their own group of virtual threads. Well, they don't have permission to security manager, but there's no more security manager, so it's deprecated already. And yes, there are only small changes to the executors. Now you just can create new virtual threads per task executor, or you can do like factory methods or start virtual threads. And there is API for that. Technically, what is good is that if you need to do your work at a thread, you simply take a thread, do your work there, and throw it away. It's so easy. You don't have to care about the thread's resources or reusing the thread. You need to do the work. You take it. It's so cheap. You put your work there. Whenever it's done, you throw away. Let the JVM, clean the garbage and do this for you. And it's very, very cheap. So as I told you, so if you now have this virtual threads, I would say it's a perfect match for our Helidon workload. So what does that mean, actually, perfect match for a Helidon workload? Each request, when it comes to Helidon, each request, so it starts a new thread. But since one request is quite, fast and quite, short in terms of time, you can simply create a virtual thread, put it there, and let it process. It means that it will not obstruct the thread. For example, you don't do, video decoding, which will take all of the thread and will simply not block. But we know that, for example, when a request comes, it will do some job, call a database, or go to the disk for some values, for some data stored on, some files. And it will block and wait for this data to come. So that means that we are not obstructing threads, but we are exactly, doing something which is short running, and there are a lot of them. Perfect match for virtual thread. So we decided to actually experiment a little bit and see what if we create our own server, which will throw away all the reactive code and process everything in a blocking fashion. Well, like we did, I don't know, I started my programming at school when I was all in the third grade. So the first code I wrote was like a recipe, like, it was fully imperative blocking code. Do this, and this. So what if we write our web server the same way as we did in school, actually? And now, as we have virtual threads, what will be the performance? And we were quite surprised that when we created this prototype, that the performance of this stuff was comparable to Netty, which was asynchronous. So we give it a code name because, like everything which is awesome, should have a code name. We called it Nima. As you know, Helidon means with swallow as a bird in Greek. So we use another Greek word like Nima, which means thread, to create our own Helidon web server. So, and we started this work. We experimented. We were in tight contact with the JVM team. So here we have some advantage because we're only one chat away with those guys. And we created our first web server from scratch, which is fully based on blocking virtual threads technology. So we have the same scalability as asynchronous programming model, but with simplicity of blocking synchronous code. So we have the performance comparable by Netty. And as you know, as Java 21 was released this September, Helidon 4 was released just 1 month after the release of Java 21. So with this, we became the world's first, let's say, virtual thread-based web server. So now we simply throw away Netty from our code, which is good because it gives you less security programs, less CVEs, less, dependencies. And we have our own virtual thread server, server-based web server, sorry. So from the out of the box, you have the support of HTTP1, HTTP2. We have our own support for gRPC. We have our own support for WebSocket. We have a wonderful unit integration test framework. That means that it's aware of the service of the how we call it of the nature of stuff happening there, like it's blocking, it's virtual threads and all that stuff. It has support for security. It's very much extensible, so you can create even non-HTTP protocols quite easy there. Out of the box, you have access log, you have course support, static content, of course, open telemetry, because you have to have observability features. Other observability features are available there for under observe endpoint, also out of the box, and still there is some stuff which has to be added, but for production ready product, you already have it out of the box. So what does that actually mean? So that means that we use the latest and greatest technologies available in Java 21 or previous minor versions of Java, like virtual threads, like enhanced switch, like sealed classes, like system logo. So we have no legacy code. This is what makes it so amazing. Written out of the box with the latest and greatest stuff. And where we are. So you must probably be thinking, okay, so what if we take the same Netty, for example, and put not a usual thread pool, but put a virtual thread pool executor, yes? And isn't this enough? And I would say here, I would try to give you an explanation why we decided not just to, submit Netty a new virtual thread pool executor, but create from scratch. So many other frameworks, our competitors, declare that they too have virtual thread support. But what they do is actually this thing. They just put the executor, which stands underneath netty or Tomcat or whatever it is, um, whatever they use underneath. Uh, sorry. Um, and put it there, and you still have this reactive overhead. And we don't do this. We simply throw away and create everything from scratch. So let's see how it usually works in older version of Helidon. So that means that if you have Helidon and you have several incoming requests, and you have here I made it only 2 threads, and you have some tasks. The red means that they're blocking and long-running tasks. The green means they're fast. So you have several tasks that Helidon has to complete. So he has few threads. So he puts tasks on the threads. Then, in a reactive way, whenever those tasks are ready, they call back using callback. They call the next task, for example, like persist to DTB or something which is blocking, and they still block the thread. So that means that if they're blocking, we can just put them on hold, I would say, and put something which is fast running. As they are on hold, they are still in the container. The other fast running stuff can call something else whenever it's ready. So that means that whenever the I would say long-running task is over, it will simply get back to the thread whenever it is available. And with this, I would say a lot of magic happening there, with a lot of callbacks, with a lot of well, once again, reactive programming, and so it means that non-blocking paradigm is used there. You get this performance. This is good. Once again, you can put this thread to have 2 threads here. You can put here the virtual thread executor, but you still have this big, I would say, reactive overhead, which simply slows things down. What we did in Helidon was Revolution. So we don't have anything reactive. We have everything blocking. So whenever a request comes, as you see here, we have 6 requests, but we have only 3 threads, for example. Other threads are simply put on hold. Now as we go from time, you see there's a make IO second thread operation, which is blocking. And I say, okay, we block here, but the JVM simply offloads this virtual threads and loads it another thread, which is non-blocking. We have 4 threads here. And start actually processing. Whenever there is another blocking operation, it will offload it once again. And the schedule will pick something which is free. And this way, as we go through time, the threads keep blocking and unblocking, and virtual and JVM knows where actually to mount or mount them. With this way, you see, the processing is extremely straightforward. You don't have any overhead. Everything is blocking. And yes, this is what makes it quite unique. The next big thing here is actually that the coding itself becomes much easier. So once again, when you do this, so I'll show you virtual thread support. So first of all, you still have reactive engine. You have several threads. You can change the threads, thread pool executor, but you have the overhead. If you remove this overhead, you have a completely blocking paradigm happening. As you see, it's processed. I tried to somehow show it in time how it is done. And the next thing is actually the programming itself. It is hard. If you took on your left, you see this piece of code is actually, it took us a while to do this. Even not me, it was my colleague who actually created it, which has this flat maps collects or whatever it is. And on Helidon for Nima, you simply, do imperative code the way you did at school, or I did at school. I'm not sure how in your country you learned this, but in our school, we learned this type of code. So you just make a cycle, submit some task, it will block, And you don't care if it's blocking or not. JVM cares this for you. Actually, uh, sorry, let us jump into some demo here. So I have created a small application. It's a movie service. So well, the reactive service was nice. So we have a web server which builds, starts. We await for duration. 10 seconds is to start, and then it's actually done. It has only 2 endpoints. The main here is even easier. We simply create server and start it. So it simply works. And then our service, if we take a look at the reactive service, for example, we have to, in parallel, this is, for example, we have to get a request from let's put it this way. So our web service, in order to formulate our response, you need to call 10 external services, and you can do it reactively. So what you do, in terms of range of several calls, you create one single or other completable feature of a client which needs to call somebody somewhere on the in the network. Then you flap map the result with function identity. I have no idea what it is, but it has to be done. Then you collect all the materials all together from the list. Then you map them movies. It's a movie service to some list, and then you actually return it. If there is an error, you do it in a reactive way, so you put it gracefully, and the result itself is returned in a reactive way. Whenever the result is available, you simply return it. So this is hard to write. It's hard to read, and I'm not sure if we're able to debug it actually. So, and it like works. What would you do with the same functionality in blocking paradigm? So this is the same call, but in blocking way. So you create some virtual threads. Yeah, then you just create a count of how many requests you want to send. And what you do, you just put the work into a future. And you, in a cycle, simply submit this work to a virtual thread pool. Then you simply get the results for each futures. You just get the results and get the responses back. So you just spread the web and then you take it back. And it will have the same or actually even faster performance than on in a in a interactive way. So I won't run it because we don't have much time. And yes, this is the most, I would say, amazing part. Even here, every call will run its own virtual threads and it will be available because it's very, very cheap. So I only will demonstrate maybe one thing here because it's main. I can simply run it from the code. And oh, I have something. I'll have to run it. Let me call it target something because my ID's messed something. Let's. Hey, where it is? Hello. Ah, yes, it should be here. JJ target Java minus jar. Hello for movies. Yeah, it started in 29 milliseconds, extremely fast. And now with the curl, I'll wait and say, for example, a lot. What will it do? It will count a million. And here, if you go to the code itself, I can say that here we just count a million each in a thread. So just in this moment, we have started 1 million threads. We do a concatenation operation and we take the results back. So at here, I just started million threads and you see my JVM did not crash. My Zoom still works. And yes, and it all is done in blocking way. So as easy as that, I would say. So nice. Let me show you another thing. Actually, I really enjoy this small project. I will only need to run it on. Oops, sorry. Here I only need to run it in some separate windows. I have a set of window groups. Like here it is. So what we have as our project is that we have a service, just a regular service, which have a get quick response, which just returns done. And we have a slow response, which actually sleeps for 5 seconds, and that's it. So that means that this response blocks the thread. We internally initially block our thread. So, and then we have a client who actually polls quick response and polls fast response. So our intention here is to show that whenever the thread blocks, we can't get any other threads working. So I will do it this way. I will start a no-loom service. Where is it? Only, oh, wait a second. More recent version. Well, what is wrong with that? Oh, let me compile it again. For sake of time, maybe I will skip this because let me see if it gets working. No. Anyway, this demo has already been shown on previous meetings, so I'll just skip it. The main idea is that you have the same performance, even better performance with virtual threads. So why is that important? Once again, well, what is actually awesome with Helidon 4 here is that whenever you upgrade with MP or with microprofile, you simply don't need to change anything. So it will simply work better. I would say much better, but like 3 times better. Although it is a blocking performance. So that means that whenever you write blocking code, it will simply work with the speed of reactive code. So we are not obstructing the threads once again. So the requests and responses are really short, and that's why it is a very good combination of what we have here. So the challenges that we have made actually here is we fought actually is that we still learn to do things asynchronously in our head. So our pattern thinking was asynchronous, and we still wrote code in asynchronous way. And it looks like if we wrote it synchronously, for example, we use synchronous sockets on Linux, the performance got actually better. This is interesting. So we really have to unlearn doing reactive and asynchronous code to get better performance. So, and even if HTTP is hard, we were able to, well, make it even faster and better, because for each connection we have up to two virtual threads that we're using it. And since we have a lot of them, it have much better performance. The same is actually for gRPC, that we don't need special netty stuff there. So we were able to run gRPC calls even on the same ports as previously. So the only thing you, for example, have to, if you're starting using the new virtual threads, you have to know the OS limitation that sometimes some virtual thread cannot be unmounted from the carrier. So if you do object wait or there are some OS limitations, you sometimes cannot offload this stuff. So that means that for join, we'll add additional threads if some of the threads cannot be unloaded. And when virtual thread is actually typically used, well, when you use synchronize block, that means that you have to rewrite your codes to Java concurrent library using the locks there. For example, oriented lock or different other sets of lock. But synchronize and native methods with foreign function usually pin the thread to carrier, and this gives you issues with synchronized code. So once again, we have to unlearn asynchronous programming to make it that fast. So just to tell a few words that now we are also trying to introduce the structured concurrency, which is still a preview, but we are already trying to use it in Helidon. So scope values, because for example, thread locals, we used to use thread locals for each thread, but now you have millions of threads, you have millions of thread locals, you can simply run out of memory. So that's why special scope values were introduced. There is a nice picture by Mario Fusco with that. So we have to replace thread locals with scope variables. But what is good that it's already available in some of the versions of Java, and Java 20, maybe 21 will be available, not as a preview feature, and next versions of Java not experimental features anymore. That means that we are about to do this. So just to be short, I'm a minute ahead of my schedule. So we had to choose between high performance and complexity. Now you don't have to choose. You just write your code in a blocking way and it reacts as reactive code actually. So, and now since Java 21 is available and virtual threads are not experimental feature anymore, and with Helidon 4, you actually have this available out of point of view based on these virtual threads. So that means that all the complexity of reactive code is now overwhelmed by Java, and you simply get a lot of performance happening there. And what is good that like a few days ago, we have the scores from composite framework scores from Tech and Power, which is the benchmark for most of the frameworks. And Helidon is the first among the competitors. And we are quite happy with this. And this is virtual thread-based running, written from scratch framework. So do we still support other versions? Yes, we still have support, open source support, of course, even from version 2, version 3. And so what is good about our GitHub our project is that although we are open source, we have a dedicated person each week who answers GitHub issues, Slack, Stack Overflow, and there is some commercial support, of course. But what makes us quite unique is that although we are not obligated to do this, but we still support on all of these channels, like Helidon, Twitter or X, and Mastodon and LinkedIn. We record videos. Whenever you have questions, just put it on Stack Overflow. There is a special guy who is not working, but on the duty today or the day you're asking, who will answer them shortly. And with this, I want to say thank you very much. So I'm a little bit ahead of time, and I really hope that you like it. And I want you to give it a try to Helidon and see how it works. So thank you very much.